And this short video will summarize the last part of section 2, what we call the segment addition postulate. So first of all, what is a postulate? A postulate is something that everybody agrees is absolutely true, even though we can't prove it. In other words, a postulate is a fact. The whole world agrees it's a fact. It's not something we can prove with logic, but it's so obviously true, we all agree it's true and call it a postulate. Well, the segment addition postulate is going to use the word between, and the good news is we already know what that means. We spent a fair amount of time in class today getting a good understanding of what it means if a point is between two other points. Here's what we found out. X is between points A and B if they are all on the same line, and we know that that word means collinear, and X is going to be in the middle of AB on that line. So they must all be collinear, and X can be anywhere in between. So between means what we've always thought, but we need to make sure we are clear that it must be on the same line. All right, well, now we can look at the segment addition postulate. We're going to abbreviate so we don't have to write so much. The SAP. The SAP segment addition postulate says the following. If some point Q is between A and B, before we go any further, let's go ahead and draw what that looks like. So they are all collinear, and if Q is between, then we can write it really anywhere in the middle. The segment addition postulate says what must be true in this case is part plus part equals whole. You see, with 3 points, we've got 2 parts. We've got the part on the left, we've got the part on the right, and we have the whole. Well, the part on the left is segment AQ, and its length is AQ. So the length of this left part, which is segment AQ, length of, notice the green segment marker, plus the length of segment QB, which is the right part, left part plus right part is equal to the whole, which is the length of segment AB. We can simplify this number, this length of AQ, by just saying AQ with no line on top. And the length of segment QB, we can just say QB with no line on top. And the length of the entire segment AB, well, we can just say AB, because when you don't put a line on top, then it means the length of the actual segment with the segment line on top. This is the segment addition postulate. Part plus whole. Whenever a point is between two other points, this little part, or the part on the left, sometimes it's bigger, plus the part on the right is equal to the whole segment. That's it. That's the segment addition postulate. I encourage you to open up to page 14 and read example 3. This is a nice, clear example using the segment addition postulate. This is going to be an example that's actually a pretty challenging problem. We have 3 points. They're collinear, but just because they're listed in alphabetical order, that doesn't mean that's the order that they are together on this line. Maybe A is between B and C. Maybe B is between the other 2 points A and C. Or maybe C is between A and B. We just don't know. So I'm going to go ahead and draw each possible scenario. Maybe B is in the middle, or between rather. Maybe A is between. Maybe C is between. We don't know. So for this puzzle, we're going to consider all 3 cases. Okay. What else has to be true? We are also given that AB is 35. So let's draw that in the picture. Here, and here, and there. We can just write a 35 in between this space between A and B, and that will tell us that the length of segment AB, which is what this says when there's no line on top, the length of the segment is 35 here as well. And segment AB here is the entire segment, so 35 is the distance all the way from A to B. What else do we know? Because there's some more given information that come next. Let's unbury it. We also know that the distance from A to C, the length of segment AC, is 93. So let's put that information in here as well. So from A to C, it's 93. From A to C, it's 93. From A to C is 93. All right, we are ready to find out what is it that they want from us in this problem. Well, they want us to communicate all possible values for BC. And this is where we will use the segment addition postulate. What does the segment addition postulate say? Well, it tells us that part plus part equals whole. So in this picture, we can say the AB part plus the BC part is the entire AC, or 35 plus BC is 93. Left part plus right part is the whole. And over here, left part plus right part is the whole. So we can say that 35 plus 93 equals the whole. And here, if we spell it all out, left part plus the right part equals the whole. And AC is 93. CB is the same thing as BC. We don't know what it is. And AB is 35. And this makes no sense. 93 plus BC is smaller. BC can't be negative. It's a positive length. So we can ignore this whole part and solve these equations. So we can subtract 35 from both sides. And there's one possible value of BC. 35 minus 35 leaves us with BC. And 93 minus 35 is 58. And here we have 128 is BC. So there we have it. Our possible values of BC are either 58 or 128.